On. Alright. So yeah, hi Joy, welcome. We're gonna carry on from the Siavula textbook learning guide thingy. We're doing functions. In the last class we had with Mosa, we did a parabolic function, no, an exponential function, two of them, which are opposing. Did I give out homework? Yeah? No. Okay, cool. Let's do these revision exercises, exercise 2-1, and then we will plot the graphs that are given, and then also give, what is that information? What do you call that information? Characteristics, yes, significant characteristics. So we're on page 52. Okay. Today is 19th Feb. Alright. And we're doing functions. And in functions, we will be revising exercise. I just want to change the view to grid lines. Yeah. Exercise 2-1 on page 52. And yeah. So problem number 1A is f of x equals 3x squared and g of x equals negative x squared. And we must find the intercepts. We must also find turning points. Axes of symmetry. We must also find domain and range. And maximum and minimum values. Okay. 1, 2, 3, 4, 5. Alright. So for f of x equals 3x squared and g of x equals negative x squared, let's draw up a table. And on our table, we will look at values of x for x equals -4, -3, -2, -1, 0, 1, 2, 3, and 4. And then so f of x. Alright, so when we substitute -4 into 3x squared, how much do we get? It's 16 by 3, which is 48. And then for -3 is 9 by 3, which is 27. For -2, it's 4 times 3, which is 12. It's 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, 12, 27, 48. 3, 0, 3, And then for negative 4, we get negative 16, negative 9, negative 4, negative 1, 0, negative 1, negative 4, negative 9, and negative 16. Okay, so that seems easy enough. It's just substituting. But it looks like the values where we have negative 3, 3, and negative 4 and 4, those are quite large, so it might be a bit of a stretch to try and plot those. So you can have a smaller graph that we plot such that that's our x-axis, and that's our y-axis. So that's 0 there. Alright. So negative 1, negative 2, negative 3, 1, 2, and somewhere there is 3. Right. So for f of x, if we start from negative 2 to, from x equals negative 2 to x equals 2, the highest value we have is 12. So maybe we can plot 5, that's too low. 1, 2, 3, 4, 5, 6, no. Let's do this faster. Okay. If I make that 5, 10, and 12 would be somewhere there. 1, 2, 3, 4. 1, 2, 3, 4. So 12 is there. All right. So at x is 0, our graph is at 0. For f of x at x equals negative 2, our graph plots at 12, way up there. For f of x at x equals negative 1, our graph plots at 3. At 0, it's at 0. And at 1, it's also again at 3. And at 2, it's also at 12 again. So it's way up there. Then when we draw our curve, parabolic curve, it does a shape like that. How far are you?
I'm still going.
Okay, so I'm noticing on your book, look at the largest that your y values are going to be, because that's going to be the vertical axis.
Yeah, I'm going to change
You're going to change
the
those?
numbering.
Okay, cool. I'll use a different color for the other one. Let's start with white. Negative 5. Negative 10. 1, 2, 3, 4. Okay. I'll use green for the other one. So at negative 2, I have negative 4, which is somewhere there. At negative 1, I have negative 1, so it's somewhere there. And I guess that's also the same there. And also there. Then this one plots like this. Yeah. Right. Now we're gonna do the actual stuff now. So we start first with the x and y intercepts. For y equals 3x squared. So our y-intercept, well, let me wait for you to finish plotting.
No, continue. I'm listening.
Okay. So for f of x equals 3x squared, do we have a y-intercept that is not a value of 0?
For f of x,
Yeah.
x squared. That is.
Hmm?
That is what?
That is not 0.
That is also yeah.
Where do we have a y-intercept?
That is not equal to 0. If we substitute maybe let's say 3 into the equation, we might get a different answer. That is not 0.
It's fine, we'll get a different answer, but that just gives us a corresponding y value. And in this case, if we use 3 for f of x, we get 27. So that's another point further up the curve that way.
Yeah.
But it's not necessarily a y-intercept. So our y-intercept in this case, if we put values of x into f of x, where x equals 0, that's how we get our y-intercept, right? So if we do that, how much do we get?
Yeah, I'm not hearing you.
Okay, then I guess I'm deliberately trying to confuse you. But what I'm asking is, how would we get the y-intercept?
By substituting 0 in the place of x.
In the place of x, okay. And when we do that for the f of x graph, we get what, 0? Okay. So that means that's our y-intercept. And then how do we get our x-intercept?
Substituting 0 into the y.
Okay. So at f of x,
We substitute 0.
at f of 0 rather, that's our x-intercept. So we don't have any other number but 0. So our graph doesn't really cut through the x-axis, but instead it touches the x-axis. Okay. Then the second thing we have to find out is the turning point. How do we find the turning point?
Substitute what do you call these numbers that we found? We substitute them into the negative b over 2a formula.
Okay.
And then that thing, and then f of negative b over 2a.
Okay. So we recall that formula of the x value is negative b over 2a, and then the corresponding y value is the function of negative b over 2a.
That's the one I was looking for, function.
Then in this case, our turning point would be minus, what's the value for b? It's 0, and a is 3, right? Therefore, the function of 0 so our turning point is the point 0, 0. Alright, so that answers the second part. How do we find our axis of symmetry?
Axis of symmetry, we use the same formula for turning point.
Okay.
negative b over 2a. And then we're going to find our axis of symmetry.
Alright. So our axis of symmetry is the x value that corresponds to minus b over 2a. That x value runs vertically from negative infinity to positive infinity and cuts through the graph so that the left part of the graph is a mirror image of the right part. So at x equals 0, we have our symmetry axis and maximum and minimum value. We don't really have a do we have a maximum value for the graph f of x?
It goes up infinity.
Okay.
And goes down infinity. So I don't think we have a maximum, but I think we can create a maximum for ourselves. Can you?
I would answer differently.
Okay.
So I would say because it's a upward smiling parabola, we only have a minimum value. So our minimum value would be this part here at the bottom of the graph, which is where the smile has its lowest point. So we have a minimum value, and that corresponds to the point 0, 0. As well as, but as for maximum, we don't have a maximum because it's not a downward facing parabola. If it was a downward facing parabola, we'd have a maximum. So where it turns at the turning point. All right. What else do we have to find?
Domain and range.
Yes, domain and range. So that's a set of x values such that x is an element of real numbers. So it doesn't matter what value of x you get. As long as it's a real number, the graph makes sense. Right? That's the domain. That's the space in which x plays. And the range is a set of y values such that y is positive, so it's greater than 0, and y is also an element of real numbers. Okay. So that's for f of x. Then for g of x, negative x squared. For g of x, which is negative x squared, our y-intercept is 0 at x equals 0, and our x-intercept is 0 at y equals 0, which corresponds on our graph to this point here. Then these are intercepts. Two is a turning point. So the turning point, again, it's minus b over 2a mapped to the point of f of minus b over 2a. And since b is 0, then our turning point is going to be 0 is to 0 because b b equals 0. 3. Axis of symmetry.
Because our b is a negative. Is a
Yes. How, like I was saying earlier, the best way to think about it is to say it is the x value that corresponds to the turning point, which is an x value that runs up and down along. Like on the number line of x, that point 2 runs also vertically like that. So it then becomes an axis. So you're moving it from, I guess, not having a dimension to just being a number to having one dimension, which is its vertical length, which you can spread infinitely up and infinitely down. And so think about it as a point on your axis, and then if you straighten a line throughout that point, that's the axis. So it's not a set of coordinates. It's not like an x and y. It's just one point of x. Yeah. Oh, you get it now.
Yeah. Because I said axis of symmetry is equals to 0 to 0. That was my answer.
Oh, yeah.
Now I get it.
So we don't have a minimum value because this graph is kind of like f of x but facing down, because it's frowning. Then the curve is shaped like that, so we only have a maximum value. So the maximum value is the point 0, 0.
In this case, you can find the turning point and the maximum point, minimum point and the turning point.
For this graph,
Yeah.
the one that's smiling and facing down, we can find what?
The maximum point and the turning point are the same.
Are the same, yes.
And then the minimum for the
first one,
the minimum point and the maximum and the turning point are literally the same. So
Yeah.
if you think about it, if you find the turning point, you definitely find the maximum and the minimum for the smiling. And if you find the turning point, you find the maximum for the
frowning one.
In a way.
That's an interesting observation for these two graphs. It's an interesting observation for these two graphs. I like that. So our domain would be also the same as that. Set of x values such that x is an element of real numbers, and the range is a set of y values such that y is negative or less than 0, and y is also an element of real numbers. So I wanted to skip j of x and k of x, but I think it's important we do them because the graphs look the same. You have a negative coefficient next to your x squared, but the one is a fraction and the one is they're both integers, but the one is negative a fifth and the other is negative 5. So how we will do that, f of x is negative 1 over 5 x squared, and g of x is negative 5x squared. And I guess we can do the same graph. Negative 2, negative 1, 0, 1, and 2. All right. So, okay, you set up your table. Great. Okay, now let's substitute. At x is negative 2, we get 4 times negative 1 over 5. It's negative 4 over 5, correct?
Yes.
And the second one is negative 1 squared is positive 1 times negative a fifth is negative 1 over 5. At x is 0, f of x or j of x in the learning guide is 0. And at f of x is 1, you also get negative 1 over 5. And at f of x is 2, we also get negative 4 over 5. We can substitute similarly with k of x or g of x in this case. And then we have negative 2 squared, that's negative 20. Negative 1 squared, that's 1 times negative 5 is negative 5. Then we also have 0 there, and negative 5, negative 20. Alright, so we can draw our graph. Since there won't be any crossing into the positive y axis, we can just draw a graph that looks like that. That's y, that's x. So we'll have 1, negative 2, negative 3, 2, 3. Alright. For j of x, our smallest value is negative a fifth. 1, 2, 3, 4, 5. That's 1. Ooh-wee. I don't want to do this. It's gonna be so long, this line. Else if I could scale it down. I wanna say negative 10, negative 20. So maybe somewhere there is 5. 1, 2, 3, 4. That's negative 1. And now take that 1 and divide it 5 times. 1, 2, 3, 4, 5. Alright. Are you seeing how small I made the other ones so that we can have a scale that includes 1, 10, and 20. Negative 1, negative 10, negative 20. Okay. That's a negative 5. That's a negative 10. That's negative 20. Alright, so with f of x, or rather j of x, at x is negative 2, we get negative 4 over 5. I'm going to use a red color. Negative 4 over 5 maps to negative 2. Negative 1 over 5 maps to negative 1. 0 maps to 0. Positive 1 maps to negative 1 over 5. And positive 2 maps to...
This graph is going to be so small.
So small, right? And then I wanna plot it out like that. It's a parabolic curve, but it's really shallow, almost flat-ish. Right? And then the second one, we've got negative 20 maps to negative 2. So somewhere there. The second one, we've got negative 5 maps to negative 1. 0 maps to 0. 1 maps to positive 5. And positive 2 maps to negative 20. Ooh, this one's going to be a little bit challenging to plot out, but I'll do my best. I hope you're doing your best there too. Yeah, it almost looks like that. So my favorite thing about these types of graphs, yeah, is that think about when you're doing the dishes, picture your plates and your bowls as parabolic shapes. So the one on top, the red one or the flat looking one, would be like a plate. And the one that's more convex, I guess, would be like a bowl. So it's like a bowl sitting on a plate. Those two graphs plotted together.
Yeah.
It's like a bowl and then sitting on a plate.
But you know, we have those bowls. I don't know, are they breakfast? No, we have cereal bowls. And then I think there's another one that's like a breakfast bowl, I think.
Okay.
I don't know, but like it's like wider. It's not necessarily a bowl. It's not necessarily a plate, but it's like a wide.
So almost like rectangular-ish with rounded corners.
The ones that we have is not rectangular. It's literally just a wide.
Oh, okay. I see.
It's really wide.
I see what you mean. I see what you mean. Like a ball that looks like this.
It literally looks like that. Literally looks like that.
Also, it's like a ball, but it's like that.
Yes.
Okay.
I use it to eat porridge.
To eat porridge. Okay. Ooh. How do you make your porridge? If you don't mind my asking.
If I mix the maize meal with
Millie meal?
Yeah, mini meal with like water, and then I put my water.
Hot or cold water?
Cold water.
Cold water, okay.
Yeah, and then the water, wait for the water to put water in a pot, and then wait for it to boil. Put a little bit of salt in my mixture, and then I put it in, stir to the consistency that I want it to be, and then I just let it cook on its own.
Oh, okay.
Just keep on stirring.
What happens if you mix the uncooked mealie meal with warm or hot water before you put it in the pot?
I don't think there's going to be much of a difference depending on how hot the water is.
If it's boiling hot?
Then it's just going to cook before you put it in. It's just going to cook before you put it in the water. So yeah, you'll just be shooting yourself in the leg with that one.
Alright. No, I asked because porridge is actually my favorite, I guess, morning pre-workout meal and post-workout meal.
Why is it your favorite?
It's easy to get into your body. And it packs the carbohydrates.
But at the same time, that thing, you eat it, let's say you eat it at 9 o'clock in the morning, 10 o'clock you're hungry.
Yeah, because it literally aids with your digestion. It makes your stomach, your belly insides, process the food quicker or better. That's what I think. But
do you eat it with like powdered milk or like liquid
no,
milk?
just as it is. I like it just as it is. I don't like to adulterate it. If I want a different tasting porridge, I'll either cook sorghum porridge, the brown one. That's delicious. And there's also a sour brown one.
Okay.
But the sour brown one, you have
I
to...
don't eat white porridge.
You don't eat white porridge. What kind of porridge do you eat?
Tea.
Yeah, that's the sour brown one.
Yeah. Sometimes my mom used to like mixing. I get a thing is like that
Coarse.
one that's very coarse and then there's sorghum, the one that you're talking
The
about.
fine one, yeah.
The fine one. So she'd mix it so that it stays in the body for longer. In a way.
Oh yeah, because the coarse one has a lot more fiber. So after eating it, you either pee a lot or you either go to the bathroom a lot, yeah.
Yeah.
Or it feels like you had a fiber breakfast, yeah. Anyway, enough about porridge. The ball example made me think of porridge. That's why. So yeah, we're gonna do our f of x intercepts and g of x intercepts. Alright. So y-intercept for negative 1 over 5x squared is what? And the x-intercept? Alright. And for g of x, or I guess k of x equals negative 5x squared. So at what's the y-intercept?
0.
It's also 0, correct. And what's the x-intercept?
Also 0.
Also 0. Okay, great. Then we're gonna do the turning point. It's minus b over 2a and f of minus b over 2a.
You don't have a b, so it's still.
It's also 0, right?
0. Yeah.
Great. I guess the same can also be said for the other function.
Yes.
So it's important to write out these steps because they also illustrate to whoever's gonna mark your answer book that you did think about it and write it down as you're processing it. There's water there from
It's
the.
dry.
Oh, because it's close to the water bottle. That's.
It's cold though.
Yeah, that's why I need it.
It's dry. Thank you though.
And then axis of symmetry is the x value corresponding to the turning point. I guess it's 0 for both of them, right?
Yes. Because B
And-
is 0.
Because b is 0, definitely. Then I guess we have a maximum value because it's a frowning curve. So our max value would be the point 0, 0, which is at our turning point in this case.
For both of them.
For both of them, yeah. Even the flat looking one.
Yeah.
Because there isn't a value of y that's above 0, 0, so that's the maximum value. And lastly, the domain and range. So the domain for f of x is a set of x values such that x is an element of real numbers, as is for the other curve. And the range is y is negative or less than 0, but it's also a real number. Less than 0 and element of real numbers. Okay. So real numbers, it's that work from grade 9. The work that has to do with natural numbers, whole numbers, integers, rational numbers, irrational numbers. Yeah, because you could have a irrational number value that corresponds to a rational y number or irrational y number. I don't know. Let's do the last curve. H of x equals 2x squared plus 4 and L of x equals negative 2x squared minus 4. Can I just quickly go for a short recess? And I'll be back.
Can't you pause it?
I don't think I can. I could have just said, I'll be back, and then quickly went out.
That's sad.
Yeah. Yes, so it's h of x and L of x. We've got h of x is 2x squared plus 4 and L of x is negative 2x squared minus 4. And we must do a plotting for negative 2, negative 1, 0, 1, and 2. So, alright, where x is negative 2, how much is h of x?
12.
12.
Yes.
Alright, positive 12.
Yes, 12.
And for x is negative 1,
6.
6, okay. For x is 0,
4.
4. And that means for x is 1, that'd be 6, and for x is 2, that'd be 12. And then for L of x is negative 2x squared minus 4.
Negative 12.
Or negative 12, okay. And for negative 1,
Negative 6.
negative 6. And for 0, negative 4. That means that's negative 6 and negative 12. Alright. Now we are going to plot. So are you noticing that as we plot these, how long our y-axis points are going, like how long our y-axis is going to stretch depends on
12
and
and
the
negative 12.
negative 12.
Yes.
Alright, so that means somewhere in the middle of that line, we can say that's our x-axis. Alright. That would be 1, 2, 3, negative 1, negative 2, negative 3. And that's 0 there. So our maximum value goes to 12 for h of x. So maybe we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we can have 2, 3, 4, 5, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. Yeah, that's 12 somewhere there. Then we can do the same, so roughly 2 spacing, that's negative 2, negative 4, negative 6, negative 8, negative 10, and negative 12. Alright. That means use the red one for the first one. Okay. So red is h of x and green is L of x. So start with h of x. At negative 2, at negative 2, and just do this so it's not confusing. Negative 2, yeah. We'll use the red. So at negative 2 we have 12. So somewhere up there. At negative 1 we have plus 6. So maybe a little bit up there. At 0 we've got 4. At 1 we have 6. And at 2 we've got a 12. We've got a 12. Then we can plot our curve to turn at the point 0, 4. Alright. I guess this one is the inverse of that. So this one is an inverse. Ish, I tried, but it's got little curves on its own. Yeah. L of x is negative 2x squared minus 4. Alright. Let's do a table quick. So I'm making a table. You can make one if you like, but it's just so you can navigate. Y-intercept, x-intercept, turning point, axis of symmetry, minimum or max value, and the domain and range. Alright. Alrighty. Okay, let's do our y-intercept for h of x, which is 2x squared plus 4. At x is 0, y is 4, and at y is 0, we don't have roots for this one. So I'll just say undefined, because let's see, minus b plus minus square root of b squared minus 4ac over 2a, that's 0, that's 0. What's b squared minus 4ac? And 2c is 4. Okay, cool. So let me show you a quick way of checking the nature of roots, because our x-intercepts would be the roots, right? I'm just gonna erase this. It's taking forever to erase. So that stuff from grade 11, yeah, the nature of roots, where we check in our quadratic formula, where b squared minus 4ac. Is b squared minus 4ac positive? Is it negative? Does it equal 0? So we want to check that specific part of the quadratic formula, because that's what tells us the nature of roots of the quadratic expression. All right. Sorry, I just broke the. Will you erase? Please erase. Yes, thank you. There we go. It's erasing. Yes, now everything is erased. Yes. Alright, so we're gonna check with nature of roots. And we use b squared minus 4ac or delta, right? Now we check for the first equation. If we substitute b squared minus 4ac for h of x, 2x squared plus 4, then b is 0, 4 into a is 2, and c is plus 4. This gives us negative 16. And if we have delta that is negative, then we don't have anywhere where the curve intercepts the x-axis.
Why did I get negative 32?
Oh, because I didn't multiply with the 2. You are very correct. Thank you for spotting that. And I think the same process can be followed with the other function, L of x, and delta is b squared minus 4ac, which is 0 minus 4 into negative 2 into negative 4. Already, because we've got 3 negative signs, here where we substitute, we're going to get a negative net answer, which is negative 32. So in this case, no intercept of x-axis. No intercept. So we'll just say x-intercept is undefined. So say at y equals 0, x is not defined, but at x equals 0, y is negative 4 for L of x. Great. Now for the turning point, which is the function of negative b over 2a, make it a bit smaller. So I have space. Yes, there we go. It's the function of minus b over 2a, or rather b over 2a, and the function of minus b over 2a, which is b is 0, so that becomes 0. But if I substitute 0 there, I get 4. And for L of x, minus b over 2a, f of minus b over 2a, then that gives me 0 and negative 4. So our turning point is the coordinate points are 0 and negative 4. And our axis of symmetry, remember, it's the x value that corresponds to the x coordinate of the turning point, which is x equals 0. And likewise for L of x is the same. Minimum maximum value. The first graph is smiling upward, so it has a minimum value. which is 0 to 4, corresponds to the turning point. And the other graph has a frown, so meaning it has a maximum value, and that maximum value is 4 maps to -4, which corresponds to our turning point. As for domain and range, the domain is a set of x values such that x is an element of real numbers, but the range is a set of y values such that for h of x, y is always greater than 4. Y is greater than 4, but it's also an element of real numbers. And for the L of x graph, the domain is a set of x values such that domain, such that x is an element of real numbers, but the y is a set, the range of y is a set of y values such that y is always less than -4, and y is an element of real numbers. So y is always less than -4 here. Never goes above -4 to like -2 or 0 or 1. So it's important when we do that to always state that part there, because it shows us where the extent to which y goes. Right, so y is always this side, right, for this part, and y is always on this end for this graph. And here it's that way. All right. Let's do number 2. So we are given f of x is -3x minus 6, and we're given g of x as mx plus c. Okay, all right. So we must find m and c if g is parallel to f and g passes through the point 1:2. Sketch both functions on the same system of axes. So we have the one straight line equation, which has an obvious equation, but the second one we have to sort of come up with the equation. But we know that the point 1, 2 is on g of x and f of x. Yeah. Where does it say that?
F and g passes through the point 1:2.
I see that, but that's more like where the sentence starts on the page. So we determine
if
the values
g of x is parallel to f.
Yes, so if
g, but they
so
put it
G,
somehow wrong.
it's how the sentence got typed out, and if it's justified, that's probably why. So yeah, so g is parallel to f, and g passes through the point 1, 2.
Okay.
So it's important to note that the point 1, 2 is on g of x and g is parallel to f. I think it's safer to start by drawing the line f of x. So let's say x, let's start off at -2, -1, 0, 1, and 2. F of x is minus 3x minus 6. Okay, what's the value of f of x at x is negative 2? It's positive 6 minus 6 is 0. Okay, interesting. Then at minus 1, we get positive 3 minus 6 is negative 3 minus 6 negative 9 negative 12. Alright, so we will have, so we've got a 12 somewhere, negative 12 somewhere there. So I just need this longer. Alright. Alright, so negative 2 maps to 0, negative 1 maps to 2, 4, 6, 8, 10, 12. Those are negatives. 2, 4, 6, 8, 10, 12. All right. And now we're told that the point 1, x is 1.
You know what I did?
What did you do?
I only planned for the graph of f of x. I didn't include. I forgot about g of x.
We're gonna have them on the same system of axes.
Yeah,
so
I forgot that.
that's how you lose marks.
I forgot about its existence.
That's how you lose marks. Remember that video of the kids?
Which kids?
The parent is asking him, so how many marks did you get? It's not marks, it's marks.
Is it let go? Mama, I see curve. It's a curve.
No, I think it's other kids. It's two boys, and I think an uncle was asking them. And they're like, it's not marks, it's marks.
And these white kids are gonna kill us. These white kids.
Marks.
These kids that go to private school.
I think in that video it was two colored boys.
You see. Class business.
Okay, so yeah, the point 1, 2 is on g of x, and they are parallel. What does parallel or g being parallel to f tell us about
They never meet.
They never meet. That's good observation. What about their gradients? What does it tell us about their gradients?
Aren't they the same? Don't they have the same gradient? If not, their gradients isn't it? Both the gradients, if they multiply together, give you negative 1.
Okay, that's a good one.
Yeah?
If they're perpendicular, they should give you negative 1. But if they're parallel, they should be the same, or like multiples of, like if you multiply it by 2, you'd still get the same type of slope. Yeah.
Okay, not bad.
So g being parallel to f implies that gradient is either the same or is, let's say, similar, for lack of a better word. I'm probably using the incorrect terminology, so whoever's watching on YouTube, you'll put there in the comment.
Correct us.
Correct us. Yeah. All right, so let's plot the straight line. I'm going to use the red. F of negative 2 goes to 0. F of... Oh, no, it's here. Sorry, my bad. F of negative 1, 2, 4. That plot somewhere there. F of 0, negative 6. F of 1, negative 9. And f of 2 is negative 12. All right. That's f of x, negative 3x minus 6. So that makes sense because our y-intercept, which is at x is 0, is negative 6. And where y is 0, x is negative 2. So those are the significant characteristics of f of x. I'm going to use the green to plot g of x. But so far we've only got 1 point for it. And now we must find its y-intercept, we must find its x-intercept, we must find its domain, range, etc. So where do we start? We can start with if we have y equals mx plus c, then where y, and so let's say our gradient is negative 3. Then where y is 2 and our gradient is negative 3 and x is 1, what's the value of c? And c is simply negative 3 times 1, which is negative 3. Do additive inverses, it becomes positive, so it's 2 plus 3, which is 5, and c is 5. So somewhere there we have our y-intercept. That means our equation is y equals negative 3x plus 5. Then this means where y is 0, x is 5 over 3, so just over. So at y is 0, 0 equals negative 3x plus 5 equals 5 over 3, which is 1 and 2/3. So it's just a little bit closer to 2 than it is to 1. And that means our straight line moves something like that.
Can we go back?
Yeah. How far back?
Go back when we started drawing this graph.
The red one?
No, the green one.
The green one.
The green one. Let's start with the green one.
With the green one?
Yes.
Should I erase everything and start from scratch?
Yeah.
Okay, cool. Let's do that. Okay, where did I lose you? I think I need to start asking that.
After you found the gradient.
Yeah.
The gradient.
The
By the
gradient.
gradient.
Here.
Yes.
Okay. Ooh, so I lost you from there.
Yeah. Where did you get the gradient from? Did you calculate it from this, the equation for f of x?
Oh, remember they're parallel.
Yes.
So the product of gradient 2 and gradient 1 should be 1.
Okay.
So let's calculate
So
that.
basically what you did was you calculated the gradient from this equation, basically, in a way.
let's do it like this. You could say that, but let's say m1 is -3 for f of x, right? Let's do that. And then we'll say m2 is just m2, and that's for g of x. I think it'll make it a lot clearer.
Okay.
Right? We know that m1 times m2 must equal 1 because...
But isn't that for perpendicular?
It's -1 if they're perpendicular.
Now what are they equal to?
Now it's just they're equal to +1.
Okay.
Because -3 times m2 will equal 1. Oh, it's supposed to be -1/3, not 3. Okay, so I was incorrect to just... You know what? Let's pause there. I want to open... Just tell me this is done uploading. Still processing. Private Math and Science Tutor. Grades 12. Mathematics learning guides. Oh no, I don't want the grade 12 one. I want the grade... Is it grade 11 where you do those M1, M2 things? It's grade 11, eh? Maths learner English. Let's do that. Let's open that learning guide just for reference, because I might also... I don't want to mislead you. Kind of rely on my memory when it's not exactly saying you're right.
Okay.
Or should it not serve you right? Analytical geometry. Oh, yes, it is. Let's just check the table of contents first. Let's check the full sequence and series. Here are two.
Okay. For parallel lines, they have equal gradients.
So M1 equals M2.
Yes, M1 equals M2. And then for perpendicular,
M1 times
M2
is
to
-1. Okay.
So I'm trying to find where it's positive 1. I don't think...
No, it's not. Yeah. It's not. That's why I said let's stop right there, because I might be misleading you with incorrect
information.
Yeah. So, okay, it's established. The gradients are the same because they're parallel.
Yes, so -3.
So we can just say M is -3. Okay, cool. So, because that's where you said maybe I lost you. Because I just substituted that along with the point that they said lies on the graph. And then I found the y-intercept. Then I could work out the x-intercept. So we're going to do that quick.
Okay, I'm back.
You are back?
Yes.
Okay, let me just finish erasing here. It takes a bit of time because I'm recording the screen as well. Alright. Yeah, it's always best to admit when you don't know or when you're unsure.
Yeah. That way you can get corrected.
Yeah, and I guess that's also how I get better at this, so my teaching can always be on point.
Okay, so same.
Yeah.
Why are we putting the C onto the graph?
Onto the graph. Okay, we're gonna get to the C. Let me just finish rubbing here. Just finish erasing here.
They're kind of like caught up.
Caught up way.
Until C and everything.
Okay.
Yeah.
We're gonna explain everything, don't worry.
Okay.
In the next few seconds. There we go. Right, so we know that they're parallel, right?
Yes.
So we can simply say the gradient of G is -3 because F and G are parallel, right? We've established that, so we're not gonna research that any longer. Sharp. Knowing that, remember our straight line is in the form y equals mx plus c.
Yes.
And we know that m is a gradient, but we've also got the points 1 is to 2 that lie on this equation, on that straight line. That means we can substitute x equals 1 and y equals 2 and m equals -3 into the same equation. So if we do that, so let's substitute m equals -3, x equals 1, and y equals 2 into y equals mx plus c into g of x, so that we have 2 is -3 times 1 plus c. Then when we solve this, we get 2 equals -3 plus c. Then if we do additive inverses, plus 3 on both sides, such that we have 5 equals c. That gives us the y-intercept of y equals 5, which is there, 0, 5.
Okay.
So now you get it. You get it.
If you don't get it,
Forget about it.
Here we don't forget about it. Get it here, we don't forget about it.
You don't forget about it. Alright, cool.
Okay.
Then we're gonna do the x-intercept.
Okay.
And our x-intercept is at y equals 0. So now we have our straight line equation, which is y equals -3x plus 5. Thank you, Google Calendar, for reminding us of our next class. So when we finish this, we'll take a break and then we'll continue with next class after like half an hour.
Okay.
Okay, fine. Sharp. Right, so now we've got the straight line equation, and our x-axis is at y equals 0, correct?
Yes.
Alright, so at y equals 0, we have -3x plus 5, then we plus 3x on both sides, so that 3x equals 5, and we divide by 3 on both sides, so that x equals 5 over 3, which
okay,
is...
So instead of doing the additive inverse of 5, you do the one for -3x.
You can do any one of them.
Okay.
Yeah, I just wanted my x to be on the left-hand side, so it reads x equals when I finish.
Okay, makes sense.
Yeah, so the point 5 over 3 corresponds to 0 on the x-axis, and now we've got x-intercept and y-intercept, and the, yeah, I guess 3 and 2/3 is closer to 2 than it is to 1.
Yes, because it's just after the half.
Just after the half mark. Yeah, excellent that you spotted that. Then we just draw a straight line. Okay, mine doesn't exactly go
We
through.
include the 1:2.
Yes, we include the 1:2, definitely, because it was said explicitly at the beginning of the problem, explicitly, that the point 1, 2 passes the curve, the straight line, sorry. Just manipulate this. Yeah. So now we've got g of x is -3 plus 5. And there you have it. G of x and f of x on the same set of x's. And we end here today. We'll continue on 21st February. And with that, thank you for attending math class today. We shall continue on Wednesday at 11. Then I'll pause this and then it will be uploaded on YouTube soonest. People will hear our conversation about porridge and bowls.